In this lesson, we're going to learn how to use random value nodes to drive our ice properties, which gives a lot of variation to our particles. So here's where we left off, and you can open up 13 curve flow end. So right now, our particle simulation is looking pretty good. We've got a lot of particles spinning together, and we have our curve moving them where we want them to be. However, all of the particles are currently the same, and the curved particles all move at exactly the same rate, so it looks a little bit boring. And we have to remember that the human brain can easily spot when something is just sort of a repetition of itself. So right now, all of our particles are the exact same size. And really, that wouldn't happen in almost any situation. So let's add some variety to these particles. So to do that, we can jump up to our emitter inside of our ice tree. And let me just expand this out so we can see it a little bit better. And we can begin plugging in some random nodes, or nodes that give us a random or a random number, into some of these initial values. So this is really a step I always do with particles after I've sort of set up the initial conditions that I like, because adding a little bit of randomness and a little bit of variety will really help any particle simulation you have. So we can either, again, in the search area, type in rand and find all the randomizing nodes, or we can find them under task and modifiers. And here we can find things such as like randomize around value or randomize color, or we can also randomize a color by a gradient. So as you can see, there's a lot of different ways to create random values. For now, let's just use randomize around value. Now let's drop this in and take a look at what this is. So currently our scale is setting the size of these particles. Now the randomized value, or the randomized around value node, looks like it has a yellow port. So this is going to be a problem because we need a green size. Now, one interesting thing about most of these random nodes is that they are polymorphic, which means that they can change output and input types depending on what is connected to them. So let's say we want to drive the size. Before connecting anything, let's take a look at what our initial size is. So currently we're saying 0.6 is about the middle, or about the center of where we want to randomize around. So let's plug our value into the size. And you'll notice that the ice tree is not complaining, because as soon as we plug that in, the randomize around value changes itself to become a scalar randomize around value. So now let's play this back, and we can see that we are definitely generating some random sizes. Now let's come in here and take a look at what's actually happening. So we can double click this. And so the randomize around value has two essentially basic properties that we need to change. The first is the base value, and that is essentially where it starts from. So right now we're starting from 0. And to this base value, we have a variance of 2, which means that Softimage comes in and randomly adds or subtracts any number between 0 and 2. Or in other words, it takes the variance, detects or creates a random number, and then adds it or subtracts it to the base value. So if we set a base value of 2, and we set a variance of 2, the range of numbers we're going to get is from 0 to 4. Or in other words, the base value minus the variance, all the way up to the base value plus the variance. So if we hit play, of course, this is going to create some oversized particles. So our initial size was 0.6, so let's set that for the base value. Now, currently we have a very large variance. Now, of course, this is depending on the size and the differences in size that we want. Let's try to figure out what an upper limit could be. So to do this, we could turn the variance to 0, and now all of our particles will just be created at a 0.6 size. So let's pull this up a little to see how large is too large. Well, if we look at 0.9, that's getting close to it. So let's say we have a maximum of about 0.8. Okay? And we probably don't want to get smaller than let's experiment around a little. Let's see what 0.4 looks like, and that's pretty small. So let's set our base value at 0.6, and then if we want to go between 0.4 and 0.8, we need a variance of 0.2. So now this randomized around value per particle is going to come in, start at 0.6, and then either add or subtract a random number up to 0.2. So we're going to get numbers out of this such as 0.7, 0.53214, 0.69224, anything in between 0.4 and 0.6. So let's play this back. And now you can see we have a much better variety of particle sizes inside of our simulation. Now, of course, if this is a little too small, we can increase either the base value or the variance. Let's just increase the base value to about 0.7. Let's take a look at this. So now we have a lot of particles at different sizes. And of course, if we wanted more variety, we would have to increase the variance. And if we wanted less variety, we could decrease the variance. Okay, so now that we have our size randomized, let's take a look at what else we can randomize. And of course, we could come in and randomize each of these values. Of course, some of them we would not really need to. For example, the random orientation probably would not change our particle simulation too much, while something like a random rate could have a drastic change on our particle simulation. So for now, let's move down into our flow along curve, because as we saw before, our speed is linear, or in other words, every single particle moves at the same speed. So I would like to have a random new speed set. So again, let's take a look at what our current new speed is. It's currently at 0.2, so we're going to want to randomize around 0.2. So let's look through our modifiers, and as you can see, there are a lot of different options. And if we want a little bit more control, we could randomize value by range. Now this can give us almost exactly the same results as the randomize around value node. It just gives us a different way of presenting the information. So the randomized value by range gives us a range of numbers, in this case 0 to 2, that it will generate a random number from. So this will give us a random number in between 0 and 2. Now, to get this exact same random values inside of the randomize by value node or randomize around value we used earlier, we would just need a base of 1 and a variance of 1. So if you have a specific range in mind, you can use a randomized value by range, and it'll be a little bit easier instead of having to think about the relationship of the variance and the base number. So our current new speed is set to 0.2, so let's say that's the minimum value we want. Now, a maximum value of 2 could cause some problems here, so let's just play this back and see what happens. So as we can see, these particles are getting a little bit too much energy, so let's lower this down quite a bit. Let's try 0.6. Now, even this might be a little bit too much energy. However, we can now see that these particles are moving at a different rate. Or in other words, they're not just slowly moving along one after another, but they're actually jostling for position. Now that might be a little bit too strong, so we can of course decrease this to something like 0.5, but I think this is getting us a pretty nice result. So the particles are flying along at different speeds, and then they jump into the second beaker. So now that we have the particle flowing along the curve at a random speed, and we have them at a random size, we can now come in and continue working on the particles themselves. So right now, if I hold Q and draw a render region, we can see that the particles are just showing up as circles. And what I would really like is for them to have a tail. So in the next lesson, we'll learn how we can use strands to give our particles a nice tail and create a slightly more realistic simulation.